Hello and welcome back to math class. A fairly lengthy video here, so I'll try to go quickly. If you don't pick it all up the first time, maybe watch it a second time. Try to take notes and let's begin. Cartesian equation of a line. Well, we've learned quite a few forms for equations of lines. Let's gather them together. Different forms of equations of lines. Well, we recently did the vector equation of a line. And from that followed the parametric equations of the line. In grade 9, we learned the slope y-intercept equation of the line. And today we're going to focus on that other form that you did in grade 9. It was called the general equation of the line, but it's got a different name. This is called the Cartesian equation, ax plus by plus c equals 0. Some call it the scalar equation. This will be the focus of today. Relationship between slope and direction. This line, this blue line, goes through fairly obviously point 24 and point 67. Its direction vector is 4, 3. This vector is 4, 3. So the direction of the line is 4, 3. The slope from grade 9, using our slope formula, y2 minus y1 over x2 minus x1, means we go y minus y over x minus x. So in this case, 7 minus 4 over 6 minus 2, and that's 3/4. So we note, we've got the direction, which is the direction vector 4, 3, and we've got the slope, which we figured out from the grade 9 method, 3/4, and there's a relationship here. So if you're given the direction, you can easily state the slope, and the other way around. A way to remember it is denominator first. In this direction, this number, the first number, is the denominator. So we're going to turn this into a fraction, and that 4 will be the denominator to get the slope. Good to know. It helps. So in general, if a direction of a line is AB, then its slope is B over A. Example, convert a line in Cartesian form to vector and parametric form. There's a line in Cartesian form. Let's convert it to slope y-intercept so we can say the slope. Okay, I did it in one step, taking for granted that you can do this. I dragged minus 6 across, I dragged 3x across and made it minus 3x and divided everything by 2. And I can see right in front of me the slope of that line. And so immediately I can state the direction vector because denominator comes first. So the direction of the line is 2 minus 3. And all I need now is a point, and I can state the vector equation of the line. So I just need a point. Any point will do, so I chose the y-intercept, although you could choose any point you want. I let x be 0, and so y would have to be 6 over 2, which is 3. So this is a point. And of course, there are infinite points to choose from. And so one possible vector equation is xy, or r, equals 0, 3 plus some multiple of 2 minus 3, the direction vector. And from this also follows the parametric equations. X equals 0 plus 2t, y equals 3 minus 3t. And this is converting from one format to another format. Using the fact that we can get the slope, that gives us the direction. Let's convert the other way. So I'm going to give you a line in vector form, and let's turn it into Cartesian. Okay? Method 1, sub a point and the slope into the slope formula. Now you might have forgotten the slope formula. Let's take a look. A point is easy to find. The slope is, well, we know this is denominator first. So it must be something over minus 3. It's minus 4 over minus 3. But wait a second, minus over a minus, let's just call that positive. So we've got the direction, we've got the point, we've got the slope, and we've got a point, and we can sub into this, the slope formula. The slope is y without a subscript minus y1 over x without a subscript minus x1, where y1 and x1 are coming from the point. Notice when you see math done like this, a formula, y is going to hang around and be the y in our result, the one without the subscript. Same with x. It's going to hang around and be in our result. y1 and x1 are going to become these numbers. So we'll plug everything into this formula, cross multiply, equal it to 0, and we've got the Cartesian equation. How did we do this again? We took a point and we took the slope, which comes from the direction vector, and we subbed into this formula, cross multiplied, and we get our result. There is another method. We could solve for the parameter twice. Remember, this says x equals minus 2 minus 3s. So we could state that out. It says y equals 5 minus 4s. Now take these equations and solve for s. Note, we're going to leave x and y right where they are and drag everything over to join them, because we want a positive x. So we'll drag this minus 2 over, make it x plus 2 over minus 3. We'll make this y minus 5 over minus 4. We've solved for the parameter twice, and since both of these are equal to s, they're equal to each other. So we equate them. Because they're both equal to s, equate them, cross multiply, equate to 0, and you get the result. So again, we can solve for the parameter twice, equate and cross multiply, or we can take a point and derive out the slope here and sub into this formula, the one that has a y without a subscript and a y with a subscript. Plug into it, cross multiply. Same result. Couple of methods. Convert the line to Cartesian form. Okay, let's do this again. Solution, let's turn this in, let's find the slope here. Now denominator first means the slope must be something over 0, 5 over 0. The line has slope 5 over 0, but this is undefined because we can't have a 0 denominator. And this is some of this trivial stuff that math teachers have been saying, is that an undefined slope is a vertical line. Just these little things that you kind of needed to pick up. This line goes straight up and down. And therefore it's just x equals minus 3. Because when vertical lines are in the form x equals a constant number. Y can vary because it's not even part of the equation. So this, be on the lookout for undefined slopes. Working with normals, the concept of a normal to a line or curve is a line that meets the line or curve at right angles. So for example, in calculus, a normal to a curve at a point is a line that is perpendicular to the tangent to the curve at that point and goes through the point of tangency. So all those questions in high school calculus that said find the equation of the tangent to the curve at the point could have been find the equation of the normal to the curve at the point. It's just at right angles. Normal axis. Every line in R cross R has this feature. It's called the normal axis. And the normal axis for a line is that unique perpendicular line that originates at the origin. And a normal vector is any vector collinear with this normal axis. So let a general point on the normal axis be n, AB. So a normal vector would be vector n, AB. Okay, let's have a look at what I'm talking about. This blue line is a line. Let's call it line L. And this is its normal axis. It's a line that originates at the origin, goes to the line at right angles. So it's not up here, it's not down here, it cuts right through here at right angles. That's called the normal axis of a line. Every line has one, and it's unique. I suppose unless the line actually cuts through the origin itself, but that's a different discussion. Now, this is the normal, this is the normal direction, AB, the normal to the line, and this is a given point. Points and x's and y's that have subscripts are known numbers that we can sub in. So this is a given point, and this would be the general point. Points with x's and y's that don't have little subscripts are the ones that are going to hang around to be in the equation. And now we can get the direction of the line. The direction of the line, of course, is x minus x naught, comma, y minus y naught. So that is the direction, because that's how you get the vector between 2 points, by subtracting backwards. And now we'll make use of the fact that the normal and the direction, they dot to 0. So let's dot them to 0 then. The normal and the direction dot to 0. We know the normal is AB, and we figured out the direction to be x minus x naught, y minus y naught. Let's take a quick look back. The direction here is x minus x naught, y minus y naught. Now these are going to be known numbers. These are going to be the x and y that hang around to be in the final formula. Performing the dot product, it'll have to be ax minus ax naught, by minus by naught, just performing the dot product. Rearranging so that the y and the x come first, and considering this is just some scalar number. It doesn't have any variables because we know what x naught is, we know what y naught is, so this is just some scalar number. Let's call that c. And so now we have ax plus by plus c equals 0, where c is this junk at the end. It's a couple of terms that we know what they are. How about that? We have ax plus by plus c equals 0. And we conclude from this that when we see this format, AB is normal. Because remember, this normal was AB. Here it is in the general equation. So AB is normal to this line, ax plus by plus c equals 0. From this conclusion, there follows a theorem in 3 parts. Given a couple of lines, line 1 and line 2, with their normals, normal 1 and normal 2, we know 3 things. The angle between the lines is the same as the angle between their normals. Now we can get the angle between their normals, and so the angle between the lines is the same as the angle between their normals. Math people always want proof, and I'm just giving this to you without proof. Later, you would see a proof of this, a rigorous demonstration that it has to be true. We'll save that for a different course. 2 lines are parallel if and only if their normals are scalar multiples of each other. Now this makes sense. If their normals are scalar multiples of each other, then their normals are, well, parallel, and so therefore the lines are parallel. This is how this is said using math lingo. Line 1 is parallel to line 2. This is an if and only if symbol. One normal is a multiple of the other normal. The if and only if symbol means the right side implies the left side, and the left side implies the right side. In textbooks, sometimes they use this. They'll say 2 lines are parallel if, with 2 f's, if their normals are scalar multiples of each other. So there's 3 ways to say it. If and only if symbol, or IFF. They mean the same thing. The 2 lines are perpendicular if and only if their normals have a dot product of 0. Okay, that's a lot of stuff, but it's also quite intuitive, and it's just the way you think it would be. It all stems from this first statement. The angle between 2 lines is the same as the angle between their normals. So if the angle between their normals is their multiples of each other, then they must be parallel. And if they dot to 0, then the 2 lines must be perpendicular. Example, determine the equation of the line that passes through a given point with a given normal. Solution, perhaps construct this line. Let's have a look at it. It has a normal of minus 5, 4, and it goes through this point minus 2, 6. So it's perpendicular to minus 5, 4, and it goes through minus 2, 6. So we want the equation of this line. Method 1, use a general point and take the dot product of its direction and its normal. So we'll put a general point on there. And so its direction will be x minus negative 2, comma, y subtract 6. And we know it's normal, and dot those two things to 0. X minus negative 2, comma, y subtract 6, dotted with minus 5, 4, finding the dot product, equaling it to 0, simplifying, and we like our x terms positive, so we can just change all the signs. How did we do this again? Put a general point on there, found the direction vector, found the normal vector, made their dot product happen, and equaled it to 0. There's another way to do this. If we know the normal, we can just sub straight into this equation, ax plus by plus c equals 0, because we know the normal here. So we could say a is minus 5x plus b, which is 4, so minus 5x plus 4y. We don't know c, though. But we can get c because we can take this point and plug it in here and figure out what c is. And so we have our c value, and we have our equation. And then let's multiply through by negative 1, because computer science people, I think it is, they want that x term positive in this format. I'm not sure why, but traditionally we make the x term positive like that. Notice the normal to the line here is 5 minus 4, and the normal here is minus 5, positive 4. What? Well, they are multiples of each other, so therefore they are the same normal. And that's the result we got the other method. What was the other method? Put a point on it, get the direction, dot it with the normal, equate to 0. It's good to have a repertoire of methods. Examples show that these lines are parallel and non-coincident. Solution. Normal 1 is 2 minus 5. Normal 2 is 6 minus 15. And we see that normal 2 is 3 times normal 1. And we conclude, therefore, their normals are scalar multiples of each other. The lines are therefore parallel. Now the question is, are they coincident or non-coincident? That means, are they the same line or are they two different lines? For the two lines to be coincident, there must exist a consistent scale factor for A, B, and C. So let's look. 2 times 3 is 6. Minus 3 times 3 is minus 15. But 3 times 3 is not minus 2. So the lines are not the same line, and so therefore they are two parallel non-coincident lines. Example, determine the angle, the acute angle formed at the intersection of these lines. So here's two lines that meet in 2 space. Examine the dot product of their directions, or we could do their normals if it was in the other format. But since it's in this format, we can just dot their directions. First of all, let's consider a dot product, length times cos. The cos of theta is the dot product divided by the product of their magnitudes. The angle between them is the inverse cosine of their dot product divided by the product of their magnitudes. Now, turning these u's and v's into these two vectors, we get this. the magnitude of u being the square root of 9 plus 25, the magnitude of v being the square root of 4 plus 49, and doing some of the math here, performing a dot product, 3 times minus 2, minus 5 times minus 7. Tidying this up, then you can turn this into a decimal and take the inverse cosine.